you. So when we were choosing our hackathon track, so we asked ourselves that where we could create a meaningful impact. So sustainability is often discussed in terms of hardware, infrastructure, or energy sources, but rarely in terms of the code we write every day. So as developers, we usually focus on performance and scalability. So if an application runs faster or supports more user, we consider it optimized. But we started thinking beyond that. What about the energy behind the performance and like the questions like these? So, inefficient code may still work perfectly, but behind the scenes, it can consume more CPU, more memory, or more cloud resources than necessary. So, with time, that translates to higher cost of increased carbon emissions. So, we realize that there is a very little visibility or standardized green KPIs in everyday development workflows, and that gap motivated us to choose the green coding track and build a solution that makes sustainability measurable and actionable directly within the coding process. So yeah, that was the idea behind this.
When we started thinking about the KPIs, we didn't begin with just technology. We began with a simple question: what actually consumes energy in a software system? So first we looked up at CPU efficiency because processing power directly affects energy consumption. So if a task can be completed using fewer computation cycles, it naturally reduces power usage. So then we focused on algorithmic efficiency. Many systems work perfectly fine, as Ria said, but rely on high complexity logic like order of n square, or you can say order of n cube, which is very heavy on the system. So these patterns may not be obvious at first, but they significantly increases processing time, and you can say energy consumption as data scales. So later we also included memory usage and space complexity. So because inefficient allocation or unnecessary data structures increases system load, more memory consumption often means more energy demand, and at the infrastructure level, it of course increases the energy usage. So finally, at the last, we kind of introduced energy use estimate, which is, you can say, not a perfect carbon calculator, but it can be referred to as an directional indicator. So it helps developer kind of understand whether their improvement are moving the code forward, with a greater sustainability goal. So overall, our entire the entire working and our principle was very simple. Like energy consumption in a software is driven by resource usage, not anything else. So that was the entire idea behind the KPIs and the detection of it.
So our goal with the CodeGreen.ai is not just to detect the inefficient code, but to help developers understand why something is inefficient and how they can improve it. So thinking of it like having a mentor sitting next to you during your coding. So for example, like if a developer write a piece of code that repeatedly calls an expensive operation inside a loop, so the system doesn't just flag it as inefficient. It explains something like this pattern increases processing time and energy uses. So you could optimize it by moving the operation outside the loop. So over the time, something interesting starts to happen. So developers begin to recognize the patterns themselves before the tool even flags them. The process become a learning loop. So it would be something like the tool detects an inefficient pattern, the developer understands the impact, they apply the suggested improvements, and they see measurable improvements in the performance or the efficiencies. So after repeating this cycle several times, so the developers naturally become more mindful about writing the efficient and sustainable codes. So instead of being just a tool that correct mistakes, CodeGreen.ai become a learning companion that gradually build awareness. So this helps organization from moving from one-time fixes to a long-term culture of responsible and sustainable codings.
In the initial phase, while researching about KPIs and defining them, we identified various best practices that can be followed by developers for the efficient codes, such as avoiding high complexity algorithms when simpler alternatives exist, optimizing the memory allocation and the reuse, uh, The minimizing the redundant computations, choosing efficient data structures, minimizing redundant and unnecessary API calls, and writing maintainable modular code to prevent a technical debt and for better understanding. So we strongly believe that Codegin AI can act as an intelligent companion for the developers. Instead of just replacing developers, it serves as a sustainability advisor, which can review code, suggest improvement, and reinforce best practices in a real time. This makes green coding practical, scalable, and easier.